Welcome back, guys. Welcome to Career Diaries. So, going to the next problem in the sliding window list. We'll be doing lead code 3090 maximum length substring with two occurrences. Given a string S, okay, within the maximum length of a substring such that it contains at most two occurrences of each character. Okay, wait. String S, okay. We are given a string maximum length of a substring, okay, such that it contains at most two occurrences of each character, okay. So we have to check the substring with maximum two, like two, should I say, the function has a length of 4 and contains at most two occurrences. Okay. Understood, guys. So you have to take a substring such that if you include b in the substring, then it should have another b in the substring. If you choose C, then it should be having another C. In this case, it won't have another A. So we should not consider A. But why is the output 4? Let's see. Given string is written the maximum length of a substring such that it contains at most two occurrences of each character. So we have two B's, two C's, and two B's again. Okay. Length of 4 and contains at least two occurrences of each character. I didn't get it. Again, the horse is between 2 and 100. Two occurrences of each character. Okay, sorry guys. It's not at least, it's at most. So we can consider B here, which have one more occurrence, and C with only one occurrence, and A with one occurrence. So it is BCBA. If we select BCB here, it's fine until this point. And if we select another B, then it's not at most three occurrences. It's at most two occurrences. But we encountered another B which makes it 3, so it fails. Since it is a substring, what we can do is, I guess it can be done in order of, I mean linear order of n. So what we'll be doing is, we will insert two pointers, one at 0 and one at next position, while 2 plus the length of s. How do we remember how many occurrences of each character is there? The So the maximum number of values it can have is 26. Guess we have to keep a dictionary kind of object or a list. Since dictionary will take so much space, we'll do one thing. First we'll check how much time will it consume for each character of the string to perform the conversion. Order of one. Guys, I just thought about a problem. We are moving through the array like this. Encountered B. We encountered C. Fine. We encountered B again. Now the B value is 2. And later we encountered B again. Now what we should do is, instead of forgetting the entire thing, we should remove this B, and the subarray substring will contain this part. And again, when we move here, we should check if it is like until what point L should be moving forward. Fine. We can do two things. One is we can create a dictionary, or we can create a list of index 26. I mean list of size 26, and we can save into one thing. We'll create a dictionary. So we are updating the dictionary. Let us optimize. Okay, 0, 2, 3. Let's see. Oh, we did something wrong. We're doing something wrong. Let's see. So what we are doing is usually P1 and P2 are side by side like this. If so both B and C are not available, so it will be 1 and 1. And in the next step, P will be 2, hmm, let us of S of P1. Okay, guys, I think I understood. Yes, we are moving P1 forward. We shall also remove P1. So we are removing P1 frequency and moving to P1 plus 1th position. And if we reduce it P2, so let's try run it. Initially, we are taking P1 and P2 at 0 and 1. So S of P2, we are inserting P1 and assigning 1 and taking a P2. Okay, okay. So if P2 already exists, then we'll be adding plus 1. And if P2 does not exist, we are creating an entry of P2 positioned element if P1 is less than P2 and the frequency is greater than 2. We will be moving. So checking if the like we are taking BC, which will be 1 in the dictionary, and here B will be 2, C will be 1, and here B will be 3. So P1 is less than P2. Okay, P1 is less than P2, which is 0, and P3 is 0, 3, and the frequency of P2 is greater than 2, that is 3. So we are checking the P2 element like this P, and this is also B. So we are reducing P2's position, P2's frequency, that is B will be -1 and B is 2 again. So now P2 is not greater than 2, so the loop will be breaked, and we will be checking the maximum of answer and P2 minus P1. Let's see how it will work. I think we should debug it. Letters P1, 8. Let's debug it. So 0, 1, and 0 and 2. It will be better if we keep it down. Like here, it will give better debugging results. So at 0 initially, we will be having B1 and C1, and we're incrementing to 2. Now B2 and C1, and later B3 and C1. So we'll be entering the while loop. Now see guys, there was now P1 was not updated, but we are incrementing P1 here. I think it should be here. Since we are reducing P1 anyway, now it will work fine. Yeah. See, the slightest differences make the biggest changes. I think it can be even more optimized. in terms of time complexity. Let's check if we are getting better, like correct results for every answer. So, but before that, let's discuss what we did here. So we're using P1 and P2, 0 and 1 statically, and we are creating like P1th position as 1, since initially the lattice is empty. So while we are into the loop, what we are doing is we are checking the frequency of the uh, each character. So if the frequency is greater than 2, then we are moving P1 until the frequency is 2 again. Let's test it out with the test case. Let's keep this open for better understanding. So one initially B1 and C1, next B2, 2 Bs and 1 C, 3 Bs and 1 C for entering into the loop and reducing the first B. Now it is C double B, 0 1 2 0 1 2 3, and we moved B forward. Now it is NCBBN, so 1 N, 1 C and 2 Bs, and to the next B, then we will have 3 Bs for entering into the loop. So we are removing C, which we don't need, but still B is 3. So we are removing the next B as well. So we will have 2 Bs and 1 N. two b's and one, and again we are adding another b. Now we have three b's again. We are reducing, and when we do this, we are having three b's again. We are reducing the n and still three b's. We are reduced n to 0. We still have three b's. Now we have two b's. So p1 is bn, p2 is b. Now what we do is, from here we'll take c. Now it is two b's and one c. Next three b's and one c. So we will remove this, and we have two b's again, one c and one a. Let's comment these logs and let's submit the problem. So it took 8 milliseconds, and the time complexity is order of 1, since no, not order of 1. The time complexity is we can say, worst case scenario, the time complexity will be, no, the space complexity will be order of 26, which is uh, constant time complexity, space complexity. Anyway, we should consider it as n. And let's check if there are any optimal solutions other than this. What he do is, he did the same thing, but instead doing it in a loop, he calculated the, I mean, he did the entire free counting thing initially in order of n time complexity. And what changed is he also had a right and left pointers pointing to the same point. And no guys, he is doing default dict. Why is he do, I don't know why he is doing default dict. He's doing the same thing as we do. Let's see how is default dict help. Oh, okay. So default dict will reduce this if condition. We can directly do this, which won't result in an error. Okay. He did same too, but he did it in a complex way. We could have done this. Let's see, let's see. So yeah, he did the same thing. It's also same. He also did the same. So it seems we did a optimal approach. And hope you guys understand what is running here, and keep pushing forward and keep learning. Bye.